Okay, so 8 minutes late, but better late than never. Welcome to the second part of today's webinar, where we will be teaching you how to create Revit models using Rhino initially, and then for more advanced use cases, we will be using the Grasshopper connector. And we will also be seeing a little bit of how to send data from Revit back to Grasshopper, specifically to help us get some types and families, but we'll see all about that in a second. A little bit about me. My name is Alan Rain. I'm a software engineer at Speckle with a background in architectural engineering and a software developer by self-teaching myself. And so with that said, let's get going. We'll be going a little bit, since this is a beginner webinar, we're going to be going through the prerequisites that you'll be needing to install in your computer and guiding you through a little bit of the setup really quickly. And we'll be teaching you how to very quickly get started creating your account, etc. in Speckle, and then teaching you the main features of the Rhino Beam side of Speckle, which is the commands that allow you to send raw geometry to Speckle from Rhino and receive it directly in Revit as native Revit geometry, such as walls, slabs, etc. That comes with some limitations. So we'll be seeing Grasshopper to have better control of all of this process. It's basically the same thing that we're going to be doing in Rhino, but with way more options. And then finally, we will have some minutes, hopefully, for questions and answers. So let's get started with the prerequisites. For this particular tutorial, we're going to be using Revit, and we support between Revit 2018 and 2022. But I'll be using Revit 2021, which is the one that I have installed in my computer and the one that I usually use for everything. And we also support Rhino 6 and 7, but I will be using Rhino 7 at this point. You will also be needing the Speckle Manager installed, which you can download at speckle.guide/user/manager. You will have also some instructions on how to use it, etc. Oh, sorry. And you also be needing to install the Speckle connectors, which I will show you here how to do, and a Speckle account that if you don't have one already, you can create one at our free Speckle server at speckle.xyz. So feel free to go along and create yours if you don't have one there already. You can also use, if you have your own Speckle server deployed, you can use that server. It's no big deal. So just to leave a little bit of note of the versions that we're using for the future recordings. In this case, we're going to be using the latest beta versions of the Speckle connectors. And the reason we're using the beta versions and not the stable versions is that there were a couple of bugs that we fixed but haven't released yet, and that we wanted to be able to use here during this webinar. I will also teach you how to activate these beta versions, which is all dealt with via the Speckle Manager. And just so for a quick note for everyone to know where to go, if you have any questions after this webinar, you can always find us at Speckle Systems. Our usual developer guides, but our guides in general are at speckle.guide, and our community forum, it's at speckle.community, which we are usually very responsive. So if you have any extra questions or problems or just random thoughts that you want to throw at us, we're always happy to hear about our users. So with that said, let's get started a little bit with the Rhino Beam features. But first, I'm going to share with you guys the Drive folder Sorry, I had it copied, but I had to restart my computer to join. So now I need to search back for it, which will take me just a second. Public docs webinar get link. Beautiful. So I'm just going to drop this link in the chat. There you go. Let me know if you have any problems accessing them. They should be openly available, but I may have missed something there. So do feel free to interrupt me if that is the case. So with that said, let's get the ball rolling. I had to restart, and I also need to open my Windows. Sorry for that. Hopefully this will take just a second. So the first thing that we're going to do is go very quickly through the manager, the Speckle Manager, and what do you need to do to install your connectors, which is something that is required before actually opening Rhino and Revit, which I have here already open. But let's forget about those for 1 minute. So when you open the Speckle Manager the first time, let me see if I can actually do this from scratch. The first time you open the Speckle Manager, you will see some sort of menu like this. If you already have an account, if you don't have an account, you will see a nice pop-up that will guide you through the process of setting up an account in Speckle, which will also guide you through the process of creating an account in speckle.xyz. Any account that you end up adding will end up in this menu called Accounts that has every single account that you can possibly have for each Speckle server. You can have multiple accounts for an individual Speckle server or different ones. There's no limitation there. And then the interesting part is the connectors. In this section is where you will install all of the different versions of the different connectors if they're available to install. If they're not available to install, usually you will have instructions to how to install them manually or where to go to download and access each of the connectors. But in this case, I mentioned we're going to be using the beta versions of each of the connectors. So, sorry for that. So we will have to first activate the option to be able to receive these beta versions. In this case, I already have it active, but for you guys, if you've just installed the manager, you would have to go to settings in the top right corner, and then there's a toggle that says beta versions of connectors. You just activate that, and after that, you need to press refresh of your page to make sure that everything is up to date. Once that it's done, once you go to the Grasshopper connector, for example, you will see that the version that you have ready to install, or the version that I currently have installed, is the version 2.2.9 beta, which is the latest that is available. And you will just have to press the install button, and everything will be taken care of you. Do note that you have to close all of the programs that may use Speckle. So if you have Revit or Rhino open, close them before running the install, or some things may go wrong. So as you can see, in this case, I have my Rhino, my Revit, and my Grasshopper versions already installed. So let's go ahead and start with did my Rhino die? 1 second. Start with the Rhino part. I'm going to open the Rhino file that is inside the folder I just shared, if I am able to. This one. And in this case, since I already had Speckle installed, the Speckle window popped up for me. But in other cases, it may not. And we're gonna see how to activate if you're not seeing, once you've installed for the first time your Speckle connector for Rhino. There's several ways to check if it's installed properly. The first one is to see if you have this toolbar, that is the Speckle 2 toolbar, that has just like the button to open this UI and the button to drop down with a couple of options that we will go through later. And the other way to ensure that it's working is to just run the command speckle and check if that command exists and works. So if that is okay, then that means that your install should be working properly. If your install works properly because you run your speckle command, but you didn't see your toolbar, you may need to activate it by going to your properties, the toolbar option, toolbars menu, and there should be a Speckle Connector Rhino option that allows you to activate these toolbars individually. So that's just a quick tip if somebody is missing these buttons that I will be using quite a lot. So let me just remove that and start from scratch. So in order to send data to Speckle, if anybody's not familiar yet with the whole Speckling concept, we need to create a stream, which is a place in the Speckle server where the data will be stored. And in this case, we can do so directly from Rhino, from the Speckle user interface. We can search for an existing stream if we have one, or if we want to, which is the case right now, I'm going to create a new stream directly from here. And this will automatically create a random name for it and set it to send to the main branch. Since this is a beginner webinar, I'm not going to get into branches much. Just think of them as different places inside your stream where you can store different sets of data, which is something that we're going to be doing today. So in order to send some data to Speckle, we just need to select it from our Rhino window, and we can set the current selection to be sent. And once that is done, we can just press send, and this will send the data to Speckle. But right now, we haven't actually done anything special to that data. This is just raw geometry that represents some buildings and some floors in the building, but it's not really a building model. No? There's no actual building information here. It's just lines and flat surfaces with no thickness. It's just a very kind of like conceptual design of what should be a building with some slabs with thicknesses, some walls, some different types of levels for your structure, etc. So now that it's finished sending, we can just go check how does this look in Speckle. As I've said, when you send something to Speckle, it gets stored there forever, or at least until you erase it. And this would automatically allow us to inspect the data online and visualize and select the different elements and do some very preliminary checks on your data. So what happens if we receive this data in Revit? Let's go check out the other side of the equation. So I'm going to open the file that I have also in the folder that I shared with everyone, which is in Google Drive. Check drives. Our company, public docs, webinar. There you go. Webinar connecting Grasshopper with Revit start. So you're gonna just open this, which is a very basic Revit file, which just has one level and a couple of families in it. And apparently my Revit has decided to die on me right now. Apologies for that. I'm just going to restart it. It appears it did not like something. Okay, so while that happens, so I will, since we need to wait for another minute, basically what is going to happen when we receive that data in Speckle is that since we haven't actually provided any information of what we want each of these objects to be, when you receive them in Speckle, we make no assumptions, and they're all going to end up being generic models. And if you understand a little bit of like the object structure in Revit, specifically they're going to be direct shapes with a generic model category. So we make absolutely no assumptions, and you get like the most generic element ever. Let's see if we can manage to do that. Beautiful. So now that we have Revit cooperating, we can go to add-ins. And here in add-ins, if your connector installed properly, you will be able to see the Revit connector and the Revit connector new UI, which is the new version of the user interface, which has a couple of extra nice features. So this is the old user interface that will eventually disappear. And let me see. And this is the new user interface, which is very similar, but has some extra options and nice features. But let's keep things simple. Let's open the Speckle UI for Revit. As you know, this is exactly the same thing as the Rhino one. It's just connected to the Revit side of things. And here we need to do the exact same operation, but this time instead of creating a stream, I'm just going to add this stream that has been created that is called Pink Edifice. We can change its name later to something more appropriate also. So when we receive this, it's going to take a couple of seconds because it's quite a big amount of data to generate in Revit. But basically, we're going to get a super generic, not very useful representation of this building because it's going to be a no assumptions made conversion. So if you had a flat surface, you're going to get a flat surface. If you had a flat wall with no thickness, you're going to get a flat wall with no thickness. Revit is not even going to know it is a wall because you haven't actually told it so. No? Which takes me to the next part. Let's see if this actually cooperates and maybe I should have sent a smaller part of the building because this contains a lot of smaller walls that were necessary to actually, there you go. So we end up having this in Revit, which to some degree may be useful, but it's not the most useful contraption in the world to have a generic model with a rebar cover structure category. It doesn't really make much sense, no? So let's see how we can actually improve this to make this process more understandable for Revit, so Revit knows what to do with these objects. No? So the first thing that we could that you will note is that we have this beam elements drop down in Rhino, and if you expand it, you will see that you have like the most basic types of Revit elements available to select: a wall, a floor, a column, a beam, a face wall, which is to create walls from NURBS surfaces. So you have like a curvy wall instead of just like a straight wall with a line. Then you have the option of specifying a direct shape, or you have the automatic option, which is the one that we're going to see first. And lastly, we have the remove speckle beam from all selected objects, which would basically undo what we're just about to do. So let's just go ahead and select a couple of objects. Let's say I want to select let me see if I can actually grab this layer. and pull it out. There you go. Let's say I want to select all of the massing buildings that I have around and specify that I want them to be strictly direct shapes. So we can just go ahead and grab the layer, select objects, and once those objects are selected, wait a second, opposite direction. I can say, okay, I can select the direct shape and command, and then it will ask me to select some geometry. So I'm gonna select the surroundings and then press enter. And then the next time that it's gonna, the next thing that it's gonna ask me is what type do I want this direct shape to be? So I can actually select from all of the different types that we support in Rhino Beam and Speckle Rhino Beam to be the type that we're facing, or we can just say, okay, this direct shape is not going to have any specific type. It's going to be just a generic. So what has happened here in Rhino? What has happened here is that when you run this command, we've actually, let me see if I can open the properties panel. When you select that object now, if you go to its user text properties, you now have this new property called Speckle Schema that is basically telling Speckle that when this is received in any BIM environment, not only Revit, but right now it's the only one we support, it will be received as a direct shape. So this is basically a very undoable kind of operation that you can, if at any point, come and manually delete. But if you ever need to delete the schemas of a certain selection of objects, we also provide the remove schema button that will basically just kill that. Are we done or are we not done? There. And we basically kill that added value that we added, and it will go back to operating as geometry. So since there's a lot of objects here and we are not really interested on spending a lot of time doing manually selections and manually specifying that I want each of these inner walls to be a wall, and I want each of these slabs to be a slab, we also provide a automatic conversion automatic routine that basically will try its best, and this is the important part of the phrase, it will try its best to figure out if each geometry should be a wall or a floor or a direct shape or a wall by face, so you don't really have to do anything with it. Granted, the more complicated your model, the more complicated it is that we will get it right, which is why we will see the Grasshopper features later on. So let's give a go at this. And, oh, sorry, I hit the wrong place. And say, okay, I want all of this model to be automatic. So I want Speckle to decide what type of geometry this represents in Revit. So if it's a flat kind of geometry, horizontal, it's gonna assume it's a floor. If it's a vertical flat, it's gonna assume it's a wall. Very kind of like common sense things. If you send a line, it will assume it's a beam or a column, depending on its orientation. And so we will see now that the Revit model, just by doing this operation, just pressing automatic, selecting all of our geometry, and letting Speckle do its thing. Now we have, if we select any random objects, like the inner walls of one of these levels, we will see that now all of these walls have the Speckle schema applied with the value of wall. So this will be sent along to Speckle, which I'm going to do right now. And once sent to Speckle, Did I miss something here? I must have missed something here. 1 second. This is the problem of doing live. Remove selection, set selection. The problem of doing live demos is that things fail even if you've tested them prior to doing them. So my specified, okay, so sometimes these things happen. So let me see if I can do a smaller version, and maybe we can just select the levels of, let's see if we can just select the floor slabs. Let's not be too ambitious for this demo. Maybe something went wrong that I wasn't expecting. Okay, the floor slabs are cooperating. Maybe I introduced something in the model that shouldn't be there. So now that we have those floor slabs, if you go see them on the website, on the Speckle server itself, you will actually notice that you're not going to be able to see much, but because, there you go, there they are. So we have our nice floor slabs here, but they're still not really thick because the only program that knows what to do with a surface and convert it to a slab is Revit. So all of the magic is going to happen when you receive these raw geometries that we've sent from Rhino with these special schemas attached into Revit. So let's go ahead and do that. So notice that since we've updated the data in our stream, now in Revit, we have this notification that we have new data to receive. So we can just press receive and we should be getting the latest data. This will completely replace the previous thing that we've received. So all of our building is going to disappear, but we're going to get some very nice looking floor slabs with their thickness. And they are now no longer generic elements, but they are now actually floor types that we can even go in and modify their boundaries. So they are like native Revit elements. This is no longer a surface that you created in Rhino. Once you received it with this Spectral schema attached, we do the hard work of interpreting these elements and converting them to native native Revit elements for you. This does have some limitations, specifically, for example, in the case of floors. We do our best to update existing elements as opposed to replacing existing elements, but there are some things that are going to be replaced anyway. In this case, for example, if you send a floor several times with several updates, it's not going to update the boundary because that is not technically possible through coding. What it's going to do is it's going to remove that floor and create a new floor in that same level with the new geometry for you. So it has some caveats to the whole workflow, but as you can see, it's quite powerful to be able to just, in the touch of like 5 clicks, start getting some raw Revit geometry in. The other thing that you may notice is that each level that has been created, each floor that has been created, now has this generated level 2006-500 name. This is because since many elements in Revit require to have a level, if you don't provide a level, like in the case that we just done, we just sent some geometry up and we received it back down in Revit. So there were no levels actually attached. The same way we do our best to create the beam elements, we also do our best to create levels if necessary. And this is something that using the Rhino beam tools is going to happen by default because there's no real way to provide the specific level name that you want this floor to be attached. That is, if the level at that height already exists, then we will use that. It's just if there's no level at that specific height that we need to create a slab, then we will automatically generate a level for you. Hopefully that makes sense. If you disagree with this approach, we would love to hear about it in our forum. We're always looking for ways to improve the workflows. So we're happy to hear your thoughts or complaints regarding this. Okay, Ryan Johnson said that it worked for you, sent everything with polysurfaces. Okay, so maybe something with my install in particular, since I've been doing some stuff while also preparing for this. So let's do another simple example to just see what we're looking at. Let's also try, instead of sending the whole building, we can do that from Grasshopper better. We will end up with the whole thing. Let's also try to send just like one floor and one set of walls. So I'm just going to change that selection to keep things simple and fast for our demo. And we can go back to Revit. And you will see that you now have a new update. We can press receive. And this will automatically replace whatever we previously received and put it back, put the new objects that we sent back. In this case, let me see if I can actually manage to do something useful here. We will have all of the elements that we sent as vertical elements are now walls. But if we send something that was a poly surface, like in this case, since we don't really know how to deal with the poly surface and convert it into a wall, it will become a generic element. No? So you can see here that there's some caveats to the whole approach. And the way to fix this is to explode these poly surfaces into smaller individual faces and apply the schema to each individual face. So let's go do that real quick, just for one level. Let me just do this and that and isolate. Perfect. I'm gonna explode. Okay, so I've exploded this. Ungroup. I exploded this and ungrouped this, and now I have these elements individually. I didn't have to ungroup them, but it was just to show you that they are effectively a separate different entity for each of these tiny walls. So now we can, but if you check and we actually go to our properties, you will see that these walls no longer have the schema, but because the schema was applied to the poly surface that was before the explosion of all of these items. So we can just select everything and apply our automatic conversion again, which once done, we can check if it did it properly. And yes, you can now see that there's a speckle schema value with a value of wall in my walls and my floor in my floor slabs. So let's go ahead and send this thing. I'm just going to set the selection again just to make sure that we have everything, because since we've exploded multiple items, like one item into multiple items, we need to update that selection accordingly and then press send. Ooh, I think we're running a little short on time. I also started late, sadly. But this is the end of the Rhino part, and we will switch to the Grasshopper side of things in a minute. So now that we have this, if we re-receive this single floor, obviously this will happen for multiple floors if you're doing this, but and trying to keep it nimble so we can actually do the explanations without waiting for the whole model to come in. Now you will see that all of these walls are now actual real walls that you can inspect. You can even change their type to something else that is available in your project, etc. So hopefully this brings a little bit insight of how you can use Rhino to generate specifically your starting conceptual models into Speckle, but you can also do some more complex things if you include Grasshopper in your entire chain. So let me just show everything and pop open Grasshopper. Remember that I already installed my Grasshopper connector, so if everything was installed properly and fine, when you open Grasshopper, let me full screen that, you should be seeing several Speckle tabs, the main one being the Speckle 2 tab, but we also have some tabs for the structural elements, which I'm not going to get into today, but they work pretty much the same as the Revit elements that I'm going to teach you. So it's kind of like 2 for 1. And then we have the Speckle to Beam tabs, which all contain generic elements that are not Revit specific, but are building information modeling specific, such as levels, walls, beams, etc. But they are a very primitive representation that has some limited functionality. And if you want to really target Revit in particular, we provide another tab called Speculator Revit, which contains specific Revit commands and nodes for you to specifically send things to Revit, which may include creating walls with specific parameters and other nice things like placing family instances, creating free-form elements, or even updating parameters directly from Grasshopper. So instead of sending geometry, you can send update instructions. So some parameters will be updated with the values that you specify. And hopefully we will get time to see all of that, but I may go a little bit fast. Feel free to stop me. I say Duncan says it should absolutely be an option for the floors to attach themselves to the level below. Interesting. I guess there will be a deeper conversation on this, but we're happy to hear your comments on this and how this could work or be useful to you. I think it's something that we could do totally. Okay, so with that said, I'm gonna first guide you through the starting file that I'm attaching in the folder, which I apologize for all the ugliness, but I hid everything into a cluster just to keep things simple. Basically, what I've done here is I've gotten this model, and using some Grasshopper magic that I won't get into, I've already pre-cooked all of the things that we need to generate all of the Revit specific elements from Grasshopper. So in this case, I'm fetching some geometry from the geometries from the Revit model. So you have to have the Revit model, the Rhino model. So you have to have this Rhino model open alongside this Grasshopper model for this to work. If you don't have this Rhino model, it will complain that it cannot find the layers and the different things that it's actually referencing. So do make sure that you have both open at the same time. And then we have some very basically grouped types of geometry, some curves that we can also send to reference our plot. So let's start with like the basic surrounding. How could we send this? In Rhino, we had this fancy automatic command, or we could go one by one selecting each of the different types. In Grasshopper, since we have nodes, it's quite more straightforward in a way, and in others it's more convoluted. So let's say if we wanted to send the terrain, this mesh over here, that one, the one that the I wonder why am I seeing more things that I should be seeing. Beautiful. That red plot that we're seeing here, we could send that terrain directly to Revit using one of the Revit nodes. I would tell you that I know how to find them, but I don't. So I would just search for it using a double click. Revit Topography, there it is. So Revit Topography requires, will basically create a Revit Topography object that once received in Revit will build itself as a terrain that you can later edit in Revit. The only thing that it requires is to input a mesh. Currently, we have a BREP. What am I doing? What just happened? Okay. I have fat fingers, sorry. So since we have a BREP, we can just convert it into a mesh real fast and send that. So once this is created, we can actually check the output of it, and you will see that the output of this this node is an object builds elements topography, specifically an object build elements Revit topography. So basically, we're creating our own like interface data that we can send to Revit to receive all of these things as native elements. And in this case, we could also specify some parameters, which I'm going to skip for now. We will see in like a minute. Johan asked me, does this topography sent to Revit would allow you to host trees or other Revit components in it? Right now, maybe. I'm not 100% sure of the limitations of sending topography with elements inside, but possibly, and if not, it's something that we could explore in the future for sure, if it's useful and it's something that you find lacking in the current workflows. But right now, we're going to keep it simple, so I'm not going to do any nesting or family instance placing. We're just going to send simple stuff, simple Revit stuff, and some adaptive components also on the side to end this. So let's actually send this to Speckle and receive it in Revit. How do we do that? Well, when we were in Rhino, we had this fancy UI that appeared that let us create this pink edifice stream. And if you click that button, it would take you to the place in Speckle where that stream lives, which in this case is speckle.xyz/stream/unique ID. So what we're going to do in Grasshopper is just copy this URL entirely and paste it in a panel, like so. And then once we have our stream and the data that we want to send, we are ready to create a send node. I don't have the vocals. Oh, that's a bummer. So basically, if we send this as is and go back to Revit, we're basically starting from, I'm going to restart this thing and I'm going to erase all of these lovely levels that we have here from the previous round, just to keep things clean and nice. Why am I not capable of doing this? There you go. Kill. Okay, I'm just restarting the file as it was before I was doing all of this, so we don't have any interference. So if we receive this in Grasshopper, or like in Revit from Grasshopper, you will see that now we have this topography element that you can actually edit its points if necessary. I wouldn't edit this by hand ever, but feel free to do so if this is what pays your bills. Ideally, this you would, if you need to modify, you would modify in the source place, in this case Grasshopper, and send it back to Revit again, which would update everything without any issues. So this creates a Revit topography. Let's also see how to create these surrounding buildings, all of these buildings. I actually want to, I don't really care about these buildings in particular being any direct, like any native BIM element, because they're not really walls or slabs or floors. I just want them to appear in my model, no, as reference context. So in this case, I'm going to create a direct shape. So if you double click and search for direct shape, you will see the node direct shape by base geometries. And this node already creates itself with a nice dropdown with all of the possible categories that you can select. So in this case, I'm just gonna select, I don't know, one that I know will appear without doing anything, site. And I can plug my base geometries in. And then the last thing that it's gonna ask me to do is to input a name for it. So let's just put site context. Just as good name as any. So now the same way we had our Revit topography, we have a objects, building elements, Revit direct shape. So let's just send one and the other all together, nicely packed in, and receive that in Revit. What time is it? 5:02. Okay, 15, around 50 minutes. I think it would take me to finish, hopefully. So now you will see that we are receiving this whole item. Previously, when we received them from Rhino, we received them as individual buildings. But now, since we've created, we've actually specified that a list of geometries, we get only one direct shape out, and they will behave in Revit as a single element. So we can select like the whole context and hide the whole context at once. If you wanted to have individual ones, you just need to graft your input, which will automatically create one direct shape per category. And then I'm just going to flatten that to keep things nice and neat. So this would be receiving, if you graft your base geometries inputs to have one item per branch, once you receive them in Revit, you will have individual buildings that they all have a site category and they all have a name site context. You could also specify a specific unique name for each of the objects that you're creating, or just assign the same name to everything. Also, it's totally up to you, but you have like total control over how this is categorized, what name does it get applied to, so it's something actually useful, and also, which we will see in a bit, access to its parameters, so you can actually pass along some parameter values that you know exist on a direct shape family in your project, and they will get attached alongside when this direct shape is created. Okay, so let's do one last basic geometry setup of our context. I also have here the plot lines of my plot, which are a little bit loosely drawn, to be honest, but it's not a big deal. And so we also have the option to send them as detail curves or model curves, which are two different nodes inside the curves category of the Revit to BIM, like the Speckle to Revit, sorry. So let's just choose a model curve for now. And you could also send them as room boundary lines if you so required, but in this case, we're not going to go into the room conundrum yet. So in this case, a model curve just requires you to put one curve in, and it will spit one curve out. So I have these 4 lines that I'm referencing from my Rhino model. I'm just going to plug them in. And from line style, to be honest, sometimes you don't really know what is accessible. We're gonna fix that in a minute, but for now, we're just gonna say invented. We're just gonna say we don't know. I really don't know what this model curve is, what its line style is. So let's actually plug that in, and hopefully, if luck is with me, this would generate our curves properly alongside with everything else. Notice that I'm incrementally adding to my objects that I'm sending, so that I'm sending everything at once, because every commit, every time I send, is like a snapshot of the entire model, that I want to generate in Revit. So now we have our nice curves in Revit that are actually native curves that you could actually edit if you needed further here. Granted, this is a simple example, but it will work with 10,000 curves if you have them and you need them to appear in Revit. Just beware, there may be a lot of job after that in Revit themselves. So once we have our basic things, the next thing that we can start thinking about is, okay, we have some levels here under the floor, and we can kind of like separate most of these geometries into our ground level floors, the objects, our foundation objects, and our ramp objects. Let's preview that, which are the ramps on the underside. And then we also have the lower floor names, the lower floor heights, and the lower floor outlines, which are the curves. This is a little bit of the black magic that I was talking about in Grasshopper that I hid on the cluster, on this massive cluster. It's basically getting the geometry and extracting the outline of each level, so we can, with that, we can create the specific floor slabs. In this case, we're just getting, let's zoom that, there you go. In this case, we're just getting those basement level outline floors. So let's go step by step. If we wanted to send the ground floor objects, the foundations, and the ramps, the easiest way to do it, to just keep things on their schedule, is send them all as direct shapes, but actually specifying each category precisely. So in this case, we would say that my ground floor objects are window stairs, specialty equipment, who knows, and let's call them masses. Sadly, this is not going to appear in Revit because I don't have that view put. I'm going to add them to site again. Specialty equipment. Let's just call it specialty equipment. It doesn't really matter for this demo. So I've actually plugged this in incorrectly. The geometry goes to the base geometries, and my name is going to be ground floor objects. I'm going to do exactly the same thing with my foundation, but I'm going to actually apply the what is it? Structural foundations type, and I'm going to call it basement foundation. And then we're also going to do the same thing with the ramps. And we're gonna categorize this to the ramps. There you go. Our ramps. And I'm just gonna call them basement. Beautiful. So this is like the simplest way to send things, specific Rhino things to Revit. It's just like sending them as direct shapes, but categorizing them properly. So at least Revit will know how to display them with a specific material, with a specific property. You can filter them accurately. So even if you're not generating real raw native Revit elements, you can still take benefit of the whole categorization and material display by category that works in Revit pretty nicely without having to do a lot of headaches of the actual conversion to native Revit elements, which we're going to see in just a sec. So we're just going to connect all of that together and align this. And what we've sent in, if we go back to Revit, and we receive that, now hopefully we would also have our specialty equipment, which is all of this lobby contraption. We could have categorized this better, to be honest, but it's just to make the point. And then we would have these objects categorized as ramps, and these guys categorized properly as structural foundations. Obviously, they are currently not very useful if they are all grouped together into one single direct shape. So what I'm going to do is just make sure that we are grafting the input and flattening the output to make sure that we create one direct shape per geometry. So we can actually get some useful model out. Graft, flatten. Beautiful. So we will fix that in the next send. So now let's actually get to the Revit interesting part. Here we have the information that I've extracted for the lower levels and for the upper levels. And this information is quite basic. It's just a name, level 0, -1, -2, -3, a set of heights. So what height in meters is this level at, and the outline, which is the actual curve in that specific height, like already correctly placed. So the first thing that we would need to control is, remember when we received from Rhino to Revit, we had these generated levels that we didn't choose to create. They just were created for us by the Speckle connector because each floor needed to have its own level attached to it. It has to live on a level. What does Stefan do with the, sorry, I was just bringing Duncan's question. What does Speckle do with geometry it can create in a certain Revit category? Good question. Like how? As far as I'm aware, if you create a direct shape, you can basically assign it any category you want. But I would love to hear if that is not the case. If some geometry is not supported, what we usually do is we fall back to either its mesh representation or its curve polyline representation, which is usually supported across the whole environment. So sometimes you will send a super nice, complicated solid that you have on Rhino, and you will end up getting a mesh in Revit due to limitations on the API and also some improvements that we are pending. But mainly limitations of the API. Yeah, it's kind of like that. I'm not sure about the model in place terminology. I've been away from Revit for a bit. But as far as I'm aware, we are creating them like literally just like a raw imported geometry that you're putting somewhere, and you can attach uh, any category to it. If that category exists, even if we don't have it in this dropdown, you would still be able to grab it. This is just a numerical value pointing to the categories in Revit. So if you know that numerical value, which you can easily get, you're good to go. We also have a trick to fix this further along in like a couple of minutes. Get back to the levels. So let's first, if we want to clear our floors, if you look for floor, we have this floor node, but we also have a Revit Floor option, which is kind of like slightly more complicated to set up than the floor option that is like our basic beam element that is generic across the board, while this one is a specific Revit floor that you can actually attach a lot of stuff to it. We're gonna keep the specific Revit floor because this is what we're aiming for this webinar. So the specific Revit floor requires a family, a type, an outline, and a level. And the family and the type, I'm just gonna invent them. Family and type for now. I will modify this in a sec with some actual real values. But for now, let's just call them family and type and call it a day. No, I don't really know what is available in my Revit project at the moment, so I will just wing it. And we also need an outline. We do have our floor outline here, so we'll just connect that to the outline. And we require also a level. So let's create also a Revit level. And this Revit level basically requires a name and an elevation. It has a Boolean to allow you to specify if you want that Revit level to create a 2D view when it's created, which is kind of handy if you're creating 30 or 40 levels. But sometimes you don't want to do that, so you can specify with a true or false here, and some extra parameters if you want to add them, which we will do so in a bit. So we can have our floor names and our floor heights as our elevation, and then we need to specify this create view. So I'm just going to say yes to all of them. I'm just going to put a Boolean toggle, put it to true, and yes, please create my views. So this would create a bunch of Revit levels, one per basement level, and then I can plug this into my level, in my level input in my floor, which will create all of the floors in my levels. In this case, there were 4 heights and 4 names, so we have 4 floors out of it. And if we send that through, and we receive, you will see that now we not only have the terrain, we also have, now the terrain is bothering me because I didn't send it with a proper hole. Just gonna kill it for now. So we see that now you also have your floor slabs and your levels, but the actual levels have actually been also created in my floor plan. Oh, Revit, stop asking me questions. So we can actually go through our floor plans of our different basement levels. We could do exactly the same operation in the upper floor heights. So we can just copy paste this nice block and do, okay, my outline, my names, and my my elevation, basically same input, but just for the upper half of the building. And I'm gonna plug both in. go back to our 3D view. Better. And there you go. Now you see that it's slowly converting and receiving and generating the levels and the floors for each necessary part of our building, including the last top floor that is the ceiling of the elevator shaft, which we haven't sent yet, sadly. And so once we've done that, we can also start taking care of the different walls and the different inner walls that we have here. So how do you create a wall in Grasshopper? Well, the same way that we created everything else. We just double click and write Revit wall. And then you will see that you have several different options here. You can create a wall using a curve and a height. You can create a wall using a face, create a wall using a profile, or create a wall using a curve and levels. No? So if we chose create a wall by curve and height, then we would have to specify the family, the type family, the baseline, the level, and the height that we want these walls to be at. In this case, I'm just gonna skip directly because we're running quite late. I'm gonna directly pop open, I'm gonna cheat. I'm gonna pop open the end file, which I prepared specifically for this purpose, which is basically the same file, but already kind of properly finished. And I'm gonna walk you through the interesting part. So up until now, we've been doing everything, inventing our family types. And so when we received this in Revit, we didn't actually get to choose what type of slab this was. It was the first slab that it could get, generic 150, which is the first one in the list. Okay, but what if you wanted to know what are the types available in your project so you can actually accurately input the things in Grasshopper to send them back? Well, for that, we will need to create, I'm going to create a new stream. You could create a branch instance stream, but I'm not going to get into that. Just going to randomly create a new stream in my Revit project, which is now called Circle Tower. Okay, perfect. And in this case, instead of selecting objects to send, I'm going to get the set edit objects filter option. And in this filter option, we have some property info values that we can, some filters that we can select. In this case, what we want to know is to send me all of the proper project information. If it has an origin, constructor, whatever information is attached to this specific project, the available levels, if we have them, or not. In this case, it's not interesting because we are generating them from Grasshopper. But what is interesting is to send the families and types to be able to accurately pinpoint what is available in the project that I'm going to send this geometry to. So we can set this filter and send. And then to receive it in Grasshopper, the same trick as before, I'm just going to copy the URL and paste it in this case, I'm going to paste it here just for you to show you raw, and then I will go to the solve part to just do it. So we can use a receive node and the stream URL to just press the button. Oh, this stream has no commits. This stream has no commits. Ah, it hasn't finished yet. Okay. That's weird. Revit is betraying me today. Sorry for running slightly late on the presentation. I hope you're still hanging on there. If you have any questions, feel free to throw them while this is thinking. I'll be happy to try and address them. Great, Liam, and thank you. I'm glad you find them useful. Hopefully, if you find any problems on things that are missing that we could potentially support, again, we would love to hear about them and see ways that we can improve Speckle in general and the workflows we enable with it, which right now I think it's dead. Dead Revit. Let's see, add-in Speckle. Yeah, like literally, I'm just sending like a couple kilobytes of data. I don't know why this has died on me, but let's do some cheating. Let's do some cheating. I actually already have a URL from testing. Do some cheating. I'm gonna put it here. How's that? So if you're doing this and in your computer, it should have worked. Hopefully, if your internet doesn't betray you, you will have a URL to input here, and then you can receive it. And once you've received it, you can use this node called expand Speckle object. Great, Ryan. Nice to know I'm the only one suffering technical issues here. So once you have this commit object, you can expand it, which is what we've done just here with this massive node. And this will basically give you all of the properties that are inside that object that you sent, which includes the project information for your project, but also a lot of information about the floors, like the different types of floors that are available, the different types of roofs that are available, masses, pipes, etc. So let's have a look at one of these. And with this, I will jump to the generative, like the generative components, which is the most kind of like interesting geeky part, and close it for the day and open questions. So now we have this Revit level thing that we can expand. Let's use the level. Let's use the floors. So that if we check the floors, we have a Revit element type object that if we expand with the expand Speckle object, you will see that it contains an element ID, like the unique identifier in Revit for that file. But it also contains a family name, the floor, and a type name, the actual types that we were previously inventing, and also a category. Let's do another category, family, type. So you have a category, the family, and the type of the specific element that you want. So with this, you can actually use it, as I'm using here in the end result, to actually physically select one of my element types, which could be number 1 or number 3, concrete, commercial, 362. So that way that you reduce the guesswork of figuring out all of this Revit specific information that you need to input in your Grasshopper file. You just ask your Revit technician to send this information to Speckle in a specific stream or a specific branch of your stream that you can then fetch in Grasshopper and make decisions of. And this could be constantly updated. If your Revit technician adds more families to the Revit project, he can just send again with using that specific filter, and it will automatically be updated. You will receive the update notification in your receiver. So there's no way, or at least it's very difficult for you to miss that you don't have the latest information available. So that was basically generating generic elements in Revit. Most of this applies to everything else. Any other object that appears here basically works in exactly the same way. The main trick is the family and type thing that is usually difficult to extract, and it's why we provide a way to extract all of those types in a specific kind of filter for you to use them down the line. In the end file, you also have an example of how to create a Revit face wall using a weird curvy wall as opposed to just a straight line classic wall, which also has a level attached. So you can automatically attach it a level just by a name if you know that that level exists in Revit already. And you also have the actual connection to do the Revit walls entirely, and what I was going to get to, which is the adaptive components. So let's imagine that, let's just zoom into there. Let's imagine that we wanted to crown our super fancy building with another super fancy parametrically driven design. So we have these surfaces here that we could send, and as we've already seen, we could just send them as direct shapes with some specific category. That would be fine. We could also send them as freeform elements. That would be an element inside a specific family inside your Revit model. But there's a beauty in sending adaptive components because they are fully native to Revit and allow you to modify these elements that you've created after receiving, which is something that you cannot do with direct shapes or freeform elements. No. So in this case, we will have the adaptive component node that, again, takes a type and a family. And basically, here, I'm just assigning the same thing to both. The type doesn't really matter because the type for all adaptive components is always the same. But the family is the name of the family that you have, or the name of a family that you have loaded in your Revit model that is an adaptive component family. And if you don't have any handy, you do have two families of this type in the, I will say it, in the folder that you have shared in Drive. So you can just load those up. Actually, in the Revit file, if you're following the Revit file in Drive, it already has them loaded up for you. I am afraid of actually doing this properly because I need to restart Revit since it's hung. Let's cross fingers. No. So if everything went well, we could, let me just grab this URL. I'm just going to send the adaptive components because since I'm having trouble, I'm not going to finish off the entire building at one blow, which would have been ideal. And technically, it's totally doable. I actually tested it this morning. In the end file that you have all of the structural elements and core elements of your building already set up. So you would just need to add your string URL here, send them, and then receive them in Revit, if Revit cooperates with everyone involved. But let's just do this one, just the adaptive components, to see what is happening. Let me add my pink edifice and receive. There you go. So now we're receiving all of these geometries that I've randomly generated in Grasshopper directly in Revit. But the beauty of this is that these guys are no longer static geometries. They are 4-point adaptive families that you can later on into your project, like months after you've actually received this, you could actually come and adjust some of those points, either manually, please don't do that, or via Dynamo script or some sort of automation, hopefully. But you could also re-receive them from Spectral. Don't get me wrong. But sometimes you don't really want to take the risk of updating a lot of things, and you just want to keep things simple. If you just need to move a couple of coordinates in a couple of places in your project, doing it manually is fine. But and the main point here is that the adaptive components do give you the option to do that. You know? So you can kind of like keep some of the parametric qualities of the things that you designed in Grasshopper and pass them through as something that you can edit back in Revit if required. And that's basically it for our webinar that overextended ever so slightly. I apologize for that. But with that said, I will take questions if anybody has them. And if not, we can continue with our lives. But I'd be happy to answer anything if you guys are left with anything to shoot. Oh, I just said Tushar's reply. Good. I hope I'm happy it makes sense for you. Do reach out if you have any doubts. Other than that, do remember that you can start our repos if you like us. It seems like a stupid thing, but it does help if you have a GitHub account and you are into open source and solutions and software. Do give us a start in our repo. And if you're not a developer, coder, geek, and you're just like a normal human being, and you can always find us at Speckle Systems, speckle.guide, or speckle.community. And especially in speckle.community, you can reach us, and we have pretty fast response times, specifically when things are not working. So if you find something that is broken, errors that you don't understand, do send them our way, and don't hesitate to reach out for any means necessary. And that's it. Thank you for assisting, and see you in the next webinar next week, hopefully.